Hello and welcome to this screencast in the adjacency and incident matrix of a graph. So I'm going to go just draw a simple graph, and this graph has 4 vertices. So just to recall, the graph is simply, now level this world is more A, B, C, and D. Okay, so if you recall, graph is a set of vertices which are joined by a set of edges. Each edge joins 2 vertices, and I've just made up this graph stuff by my head. Okay, so straight away, so let's talk about the adjacency matrix. Now, adjacency matrix has the same number of rows and columns as vertices in your graph. So in the case, we have 4 rows and 4 columns in the adjacency matrix. Okay, each row of the adjacency matrix correspond to one of the vertices, and likewise with their columns. So I'm just going to label columns ABC, rows ABCD, and columns ABCD as well. Okay, so what the adjacency matrix is, if 2 versus CS are adjacent, and that by that mean they're connected with an edge. For example, here are AB are adjacent because we put 1 in adjacency matrix corresponding to the row of 1 vertex and the column of the other. So in this case, AB, I'm gonna put 1 in here. Okay, in addition to AB, AC is also an edge, so we've got an edge joining A and C. Therefore, A and C are also adjacent. So here is my row corresponding with the vertex A. So I also put A1 next to AC. Okay, well, the element corresponding to AC. Okay, finally D. As you notice, down here is not adjacent to D. There is no edge joining A or D, so I want to put a 0. Okay, in that elements. Okay, so I've done the first row just to make things easy. You might notice that we get a vertex in never adjacent to itself in this case, so we haven't got looping around back to. So in the main diagonal, I'm going to just insert 0 so as in that adjacent to A, B is that adjacent to B, and so on and so forth. Okay, let's move on to the next element, B. Okay, well, B is adjacent to A, so I put A1 in here. B is adjacent to C, so I'm gonna put 1 in here. And finally, B is adjacent to D, so I'm gonna put 1 in here. Okay, that's the vertex B done. Move on to the vertex C. C is adjacent to A, so I'm gonna put 1 in here. C is also adjacent to B. We've got A1 in here, and finally C isn't adjacent. There's no edge joining in C and D, so it's okay, 0. Okay. Lastly, D. The only element of the only vertex, sorry, but D is adjacent to is B, so it's gonna be all zeros apart from the B column, which is 1. Okay, and that's the adjacent matrix for this graph. You might notice the adjacency matrix, or this one symmetric, and now this is general rule for all adjacent to matrix, because they are always square, they're also going to be symmetric. Okay, let's move on to the incidence matrix. Now the incident matrix is slightly different. We start by forming a matrix of the same numbers of rows as we have vertices. Okay, so in this case, I'm gonna have 4 rows. Now with the incidence matrix, each column represents edge. Okay, so we loop through, we'll go through all the edges, and we put 1 next to the vertices, which the edge joins. In this case, if I take the edge AB, I have an edge AB. So if I'm going the down column, this edge joins A to B, and no other. This is okay. So in this case, column defines edge AB. Okay, let's move on to AC. I have the edge AC here, so next column have the one next to A, A1 next to C, zeros to B and D. Okay, for this edge here, joining B and C, I have A1 next to B, A1 next to C, and 0 remember about instance matrix is each rows represent the vertex and each column represent an edge. Okay, so I'm gonna have a look at a further example. Just gonna scroll down a bit. I'm gonna define another graph. This one slightly more complicated. Just try and make it a bit complicated than what we've seen before. I'm gonna start off just drawing a cloud of vertices up with some edges. So what we have here, DE and G. So let's just make up some edges. Oh, I might draw that edge again. So A to F, C to F, A to C. Why not A to D, D to F? I'm gonna have F to G. I'm not going to make this graph here. I'm going to make it unconnected. So you notice we have some vertices which are not connected to the main graph here. Okay, so we start with the adjacency matrix. So I have 1, 2, 3, 4, 5, 6, 7. So I'm gonna have 7 rows. So I have 7 rows in my adjacent matrix. Okay, I'm gonna have 7 columns. I'm gonna label the columns as well. Okay, so start with vertex A. A is not linked or not adjacent to B. So I put 0 there. A is adjacent to C. Likewise, it's adjacent to D. It's not adjacent to E, it's adjacent to F. And it's not adjacent to G. Okay, so that's the first row then. And also A is adjacent to itself. Okay, second row, B is adjacent adjacent to A. Also, it's not adjacent to itself. And the only B is adjacent is actually. So it's gonna be 1 in the column and 0 elsewhere. Okay, vertex C. C is adjacent to A. So it's not adjacent to B, and the only other elements are vertex is also adjacent, and all other are 0. Okay, D is adjacent to A and F. So A and F are gonna be 1s, and everything else is gonna be 0. E, that's meant to be an E down here, so tied up. E only adjacent to B. So you're gonna have 1 in the B column and 0s elsewhere. Now F is adjacent to E, C, A, D, and G. So A, C, D, and G, and we're gonna have 0s elsewhere. And finally we have G, which is only adjacent to F, and 0s elsewhere. Okay, so that's the adjacency matrix of this graph. So it's a 7 by 7 matrix because there are 7 vertices, and as you can see, it is also symmetric about the main diagonal. Okay, that's the adjacency matrix. About the instance matrix. Well, remember the instance matrix has 7, or in this case has 7 rows. This number of these C's. And G, each column is going to represent the edges. How many edges do we have here? So we have 1, 2, 3, 4, 5, 6, 7. Well, this is also going to have 7 edges. This is also going to be coincidence. Okay, so the first edge, let's say A, C have edge going and A and C, and therefore have 0s in all the other rows. That's my first edge. Got an edge joining A and M, so A 0, 0, 0, 1, because that corresponds to F, and a 0 at the bottom, A to D, so for 1 next to A, 0, 0, 1 next to D, and also the other are 0. Okay, C to F, so I have 1 next to C, 1 next to F, zeros elsewhere. So FG, so next to F and G, zeros elsewhere. And finally B to E, so A1 next to B, and A1 next to E, and zeros elsewhere. Okay, so that's the adjacent. Sorry, the incident matrix for the graph there. And one final thing about the incidence matrix, if you want to degree of a matrix, your degree is a number of edges which intersect vertex. So in this case, has 3 edges. There, and there. That can be found by summing the row of the instant matrix corresponding to the vertex. So in here, we sum the row of A. We can see 1 plus 1 plus 1. So the degree of the vertex will be 3. Okay, and that's adjacent Y matrix and instance matrix of the graph.